a video on slicing or cross sections perpendicular to the y-axis. Again, to save time, I've already drawn out the two equations that we're working with, establishing our bounded region. In this case, we have the equation negative y squared plus 6y minus 5 equals x, the quantity of y minus 1 squared equaling x, and I found the points of intersection to be at 0, 1, 4, 3. I'm going to blow this up just a little bit. So I've got this region here that basically is doing this. And what we want to do is create cross sections or bases that are bound to this region that will be sliced perpendicular to the y-axis. So we have this slicing going on, or these cross sections. And then of course, because this is bounded to that area, it then comes out, it protrudes out of the paper in various ways, and they'll tell us how to do that here in a second. So I have to establish what my base would be. When you are crossing into the, or crossing, or slicing, however you want to say it, into the y-axis, you have to go right minus left. My rightmost function is that red one. So I'm going to establish my base. My base will be negative y squared plus 6y minus 5. Then I have to subtract the y minus 1 quantity squared. So I'm going to go ahead and square that. I can do that in my head. That would be y squared minus 2y plus 1. And you see, really, this is the most challenging part of the problem. I've got to be able to simplify this. So I'm going to take this to be my base. If I have negative y squared minus a y squared, that's negative 2y squared. 6y minus negative 2y would be plus 2y. 6y plus 2y is 8y. And negative 5 minus 1 would be negative 6. This would be the equation, so to speak, that establishes that distance from the left, from the right minus the left. So I got to go right minus left, right minus left. The red minus the green, right minus left. Now, as I've established this, and now it's just a matter of plugging it into what they want me to do. So I've got a series of problems here. And we'll go back and forth to what I just wrote, so stay with me. I need to do an equilateral triangle. In order to find equilateral triangles, I go to that formula that I presented in a previous video, and I'm just going to keep recycling it. You do it over and over again, but don't just do it blindly where you go, okay, I'm just going to use that formula that was already given to me. Sometimes these will change up a little bit, and you have to think about the change up that they throw at you. So on this one it is pretty straightforward. My volume would equal the integral. Now because this is perpendicular to the y-axis, I'm interested in these y values. So I'd go from y equals 1 to y equals 3. So I go y equal 1 to y equal 3. And for an equilateral triangle, we said that that formula would be radical 3 over 4 times the base squared. Well, my base, I just established that to be negative 2y squared plus 8y minus 6. That needs to be squared. dy. So this is part of the formula. 1, 2 dimensions, 3 dimensions, which would give me my volume. To do squares, well, squares is pretty easy. It would be the integral from 1 to 3. A square is just the base times itself. So this would be negative 2y squared plus 8y minus 6 squared dy. 1, 2, 3 dimensions. For semicircles, I go from 1 to 3. Our formula was going to be 1/8 pi, or pi over 8, whichever you prefer. And you can even take these to the outside of the integrals. 1/8 pi, the base squared. Again, you look at the previous video if you're not sure where I'm getting that from. It's just a formula that works for semicircles when you're doing cross sections. For the 45, 45, 90 with the hypotenuse in the bounded region, it would be the integral from 1 to 3, 1/4 your base squared. This is the one that sometimes you'll see gets changed up, because what they'll do is they won't have the hypotenuse on the bounded region, they'll have one of the legs, which would change the formula. You'd have to go back and redraw it to figure out what that newfound formula would be. Now I do have another one of these, and this is going to be the trapezoid, and I changed this one up a little bit to see if we could figure out what this should be. Get some paper here. Alright, so on this one it says a trapezoid with exterior base 5 times the bounded base and a height that's 2 times the bounded base. So I'm not sure what that formula would be. I'm probably going to need to draw a cross section. So here would be my base, and that's the same formula, the same expression that I keep using here. But in this situation, they're giving me a said height that's going to be twice the bounded base. So this would be 2 times the base, and it's a trapezoid. So they're telling me the exterior base, the one that's not disclosed by the region, is 5 times that. So that's 5 times the base. Now I got to put that together for the area of a trapezoid. So I say my area, I know that to be 1/2, generically, B1 plus B2 times H. And I'll specifically put this together. I'm going to use B for base right now, and B is in this base. So I say I've got 1/2 this base. The base up top is 5B. And the height is 2B. And so then I have to simplify that and see where it takes me. So fortunately, the 1/2 and the 2 could cancel out. And B plus 5B is 6B. 6B times B would be 6B squared. Which means that when I want to do this volume now, I can simply say the volume equals, and I'm just recycling what I used a minute ago. I'm using all this stuff here. It's going to be the bounded region from 1 to 3. So the integral from 1 to 3 of 6 times that designated base. See how crucial that is, because I just keep reusing it again and again and again. If you make a mistake there, all your problems are wrong. So I say negative 2y squared plus 8y minus 6 squared dy. And you see how each one of these is pretty much the same problem over and over again. You're just changing by the formula. For equilateral triangles, it was rad 3/4 base squared. That's an area. The dy becomes the volume. Squares, it's the base squared. That's an area. dy becomes the volume. Semicircles, 1/8 pi base squared. That was the formula we established in a previous video. That's an area. dy becomes the volume. With the hypotenuse being bounded on a 45, 45, 90, the formula was 1/4 the base squared. And then we just came up with this trapezoid one, Now this was specific, so and that's what I was alluding to earlier. You have to watch your problems. Sometimes they're going to give you a little bit of a curveball. You have to be reading those. Don't just blindly take a formula, throw it in, and say I'm good to go. Make sure you at least draw your figure if you have any inkling of doubt. Make sure you have that drawn and that you are establishing a formula for your area. And that's what I did here. I had a formula for my area, so it was 6 base squared dy. There's the area. That dy becomes the volume. And so now you've got some examples to look off of for how to do slicing perpendicular to an x-axis, slicing perpendicular to a y-axis, and then a generic set of videos that gave you some formulas that should help you get through this section.